Hey everybody, this is Larry. This is the first day of March. So if you finished February and did all the problems, congrats to you. If this is the first time you've done anything like this, well, welcome. It's fine. I'm going to do it for the rest of the month along with you. Hope you're having a great day. If hope something great happened to you today, as someone always said to me. Okay, so while you're here, hit the like button, hit the subscribe button, join me on Discord, and let's look at today's problem, distribute candies. I usually solve these live, so if I hesitate or to go a little bit slowly, just fast forward or whatever you need to do. I trust you. But yeah, okay. Alice has and candies with I've candies. Can you type? What? I mean, I think when you eat stuff, you just gain weight. You don't have to see a doctor about it. But okay. Um, only eat half the candies and maximum number of different type of candies on the following rice. Okay, what does that mean? Okay, so okay, so these are the candy type. It's very okay. So my thought about this was that it's a little bit confusing because it seems a little bit simple, but in the sense that my thought in my mind is gonna be greedy algorithm, right? And I think there's nothing to it. I think it's just greedy. If you eat as many candy as you can, and that is of different types, and that's pretty much it. And then if it's less than n over 2, so if I would have to guess, and I could be wrong on this one, and I think on my mind I was just thinking about how it can be, but I would write something like return, let's say min of collections dot counter of candy type dot or length of this. So either the length of this, the number of unique types, or the length of candy type divided by 2. Yeah, is it always even? Or like, okay, n is even, so something like that, right? Let's use the other candy types and take a look. And I'll explain the code in a second. And this is very greedy. It's just really, take every candy that you can and do what you have to do, I guess. And yeah, and I'll explain my code and I'll go over the code and the dot process if it's accepted, which it is. So what is the complexity of this? And some of this, as you saw me doing this live, I didn't write this code to make it impressive, to make it look smart or whatever. And I think this is an example of terrible code. I'm gonna admit that, but it is the code that I might write in a contest because you could see that I typed it in very quickly. I was confirming it and I submitted. I got everything in maybe a minute or something like that. I hesitated a little bit because for contests I would handle it a little bit different from a video, even though I am doing them live. In that, in a contest, I would probably type out the code without thinking about the proof immediately, or while I'm typing, I would think about the proof. But here on my video, my transparency to you is that I think about trying to prove it first. I don't YOLO as much. But that said, I was kind of my confusion was also just a little bit that this was a little bit like whether this was too easy or something like that. But that's okay. So the idea here is, the idea behind, there's the two things I want to explain. One is the idea behind my code, and then how I would write it in a more English kind of way, meaning how I would describe it. Because I made a couple of reductions in my head and I jumped ahead a couple of steps. But the idea here is that, okay, so this particular chunk of code, this half a line of code will tell you how many number of different candy types that this has. And actually, I use collection.counter, but you could have actually just do set. So that would have been a shorter. So this is the number of different candy types. And so basically for each different candy type, we would try to get all of them, right? And however, the only time that we cannot get all of the different candy types is if that is more than n over 2, where n is the number of candies. So if that's the case, then you just take n over 2 because you can only eat up to half of those unique ones anyway. So that's basically the idea. This is also obviously just the number of total candies. And if I were to write it in a clean way, because this looks very, even though I did do it live as you saw, this looks very unreadable and you have to explain it, right? And ideally, you don't, especially for an interview, you want to write code that is readable and not needing to be explained. Well, I mean, you probably should be able to explain it, but you don't have to, right? And even though I had collections that counter because it's just something that I'm used to typing, but set works the same. And just to be sure, just to be clear rather, this is going to be O of n times converting a list to a set, and I think this is O of 1 or O of n depending on your language, but either way, this is going to be dominated or at least O of n, and then that's pretty much it. Once you do that, this is just a min function, which is O of 1. So this is linear time and linear space because we use the number set. There are different ways you can play around with this algorithm as well to optimize for certain different things, for sure. Is this sorted in any way? If this is sorted, you could take advantage of some probably there, but it seems like not. So to write this a little bit cleaner, I'll write something like n is well, I'll set up n, and then I would, I think this code is actually now cleaner now that it's set. But you could have also like maybe some yi in candy type is you go to set, and then you go for candy and candy type. We do yi in dot add of candy. If yi in, maybe you could write this in different number of ways, of course. But if I would write something like this, maybe, or maybe technically it's cleaner to just put it on the other side. But then we return. Yeah, then we return the length, right? Otherwise, at the very end we just return the length of this, and that's pretty much all you have to do. And this is a little bit clearer because in English you can just say that, okay, for every candy that comes in, we could yeet it, and if we have yi in at least half the candy, then we're done. That's pretty much it. And if you don't have and this greedy works because if you have multiple candy of the same type, it doesn't matter whether you yeet it after the first one, because after the first one, let's say you have 6 candy type 6, after the first one you could yeet the second one, you could not yeet the second one. It doesn't change the answer no matter what. So because it doesn't change the answer, we could greedily throw it away and not yeet it. So that's basically, in terms of the answer, so that's basically the idea here. And this is also going to be linear time and linear space because of the yi in. You can also reduce this by sorting the candy types and then just do a linear scan from that. So in that case, which I'm not going to code up, even though it's like 2 lines of code, maybe 3 lines of code, is n log n, but over 1 space. So if you want to optimize for space, that's the way to go. That's all I have for this problem, I think. Let's take a look at the hint to see if there's anything, whatever. Okay, what? Okay, so yeah, I guess that's basically what I said. So yeah. That's all I have for this problem. Let me know what you think. Hit the like button and subscribe button. Join me on Discord. And yeah, have a great day. Take care of yourself. Take care of others. If you, find yourself in a fortunate place, feel blessed, feel happy. Be good, do well, and to good mental health. And I will see you next time. Bye bye.